Okay, so we left off with passage 5, the tektites, which was our conflicting viewpoints in the ACT prep packet, and we went through the answers here. So 1 was A, 2 was J, 3 was B, 4 was F, 5 was C, 6 was F, 7 was C. And so the conflicting viewpoint here was looking at these structures called tektites that, do they have a terrestrial origin, like from Earth, or are they extraterrestrial, aka lunar? Okay, so let's take a look at basically scientist 1 and scientist 2 viewpoints. So right away in the introduction, it revealed the issue at hand. Mostly these structures called tektites, which are small glassy objects found in areas called strewn fields. And the conflict is, where do these objects come from? So scientist 1, right away in the first sentence, said they are certainly extraterrestrial, probably lunar in origin. And scientist 2, in their first sentence, what they did is they refuted scientist 1's viewpoint by saying non-local origin is extremely unlikely given the narrow distribution of tektite strewn fields. And then they go on to say something like probably formed by meteorite impact. So what they did is they refuted scientist 1 and then went on with what they thought the origin of tektites is from. So to look at scientist 1 with the space origin, okay, the extraterrestrial origin, they basically have 3 points of data. Okay, and I don't expect you to recognize them right away, but the first point of data, tektite shapes show characteristics of air, friction, melting, which means that they fell through the atmosphere and friction melted them, supporting the theory of space origin. A second one talks more about the atmospheric forces wouldn't be great enough to shape tech-like material ejected from Earth's surface, so they tried to weaken the Earth origin, and I'll talk more about that. And then the third is that tektites resemble moon rocks gathered by Apollo 12, not Earth rocks, thus strengthening their space origin. Looking at scientist 2 with the Earth origin, they said that any matter coming from space would fall over a wide area. Well, with the tektites, they're found in concentrated areas called strewn fields. So they're like, there's no way they're extraterrestrial because, they should be spread over a wide area. In this case, they're only found in certain areas. There are striking similarities between tektites and the composition of the Earth's crust, thus strengthening the theory of the Earth origin. And finally, they say that meteorite impacts could create shock waves, explaining this air friction that scientist 1 proposed with the extraterrestrial. So they're just strengthens the theory of origin by counteracting scientist 1's viewpoint on that. Okay, so obviously, like I said, you won't have time to write out the supporting data for each theory, but you could go back and circle or bracket or underline key phrases. But what's really important is that you just kind of have an idea of what the data supports and what data supports which theory. Okay, so let's take a look at question 1 in our packets here. The discovery that many tektites contain unmelted crystalline material wood. So they're asking, how would it affect scientists' arguments if it was discovered that they were unmelted? Well, scientist 1 is the only one that really mentions that tektites have no unmelted crystalline structure, so it would be A, tend to weaken scientist 1's argument. Okay. Question 2. States, which of the following is a reason given by scientist 2 for believing that tektites originate on Earth? Well, you had to identify which answer choice was used by scientist 2 to support that argument that tektites were terrestrial in origin. So choice J, okay, material ejected from the moon or beyond would eventually have been much more widely distributed on Earth, expresses scientist 2's first data point. F is scientist 1, where it says the density of the Earth's atmosphere would prevent any similar lunar or extraterrestrial material from reaching the Earth's surface. As for G, tektites have a composition totally unlike that of any other material ever brought back from the moon. It's basically saying that tektites do resemble Earth materials, but it never says that they don't resemble lunar materials, and H kind of gets the backwards deal of that. So J was your answer for question 2. Question 3 was talking about scientist 1. Scientist 1 could best answer the point that some tektites had vesicles filled with gases in the same proportion as the Earth's atmosphere. So you needed to find the best way for scientist 1 to counter the point Right away, you can eliminate C and D because it says suggesting that these gases might occur in the same proportions in the moon's atmosphere. No, we're not talking about moon's atmosphere here. Showing that similar vesicles filled with these gases in the same proportions are also found in some terrestrial volcanic glass. So you eliminate C and D. Choice C because the moon is nothing like Earth, and choice D because it's actually scientist 2's claim. Choice A, maybe you selected choice A, but it's not the best argument. So choice B, however, was your best option. Demonstrate that molten material would be likely to trap some gases while falling through the terrestrial atmosphere. Question 4, how do scientists 2 answer the argument that tektite-like material ejected from the Earth could not reach a high enough velocity relative to the atmosphere to undergo air friction melting? So you're asked how scientists 2 answered the argument that tektite-like material ejected from the Earth could not reach a high enough velocity to undergo air friction melting. So again, you're looking at scientist 2's third data point on that. So the correct answer was F, by asserting that a shock wave might cause a momentary change in atmosphere density, permitting subsequent aerodynamic heating. And then finally, it's not the final question, shucks, there's 7 questions here. Question 5, the point of subjecting lenses of tektite glass to a heated airstream. So why would you do that? Well, to reproduce the effects of the atmospheric entry. Okay, so that would be scientist 1's data point with the air friction melting. So we're trying to reproduce the effects to see if, hey, could it really be the extraterrestrial origin? 6 shows why it's important to keep the viewpoints straight. Researchers could best counter the objections of scientist 2 to scientist 1's argument by, well, you can't counter the objections of scientist 2 to scientist 1's argument unless you know what scientist 2 was objecting to. So going back to scientist 2, his issue with the idea that lunar material could strike the Earth without being dispersed over a far wider area than the known strewn fields. F is your best option on that because if we found some force capable of removing tektite-sized objects from orbit quickly, then it would demolish scientist 2 in their first opening paragraph. So again, yeah, maybe you're lost at this point. That's okay. Viewpoints can be pretty confusing at times. Finally, question 7. Which of the following characteristics of tektites is least consistent with the theory that tektites are of extraterrestrial origin? So we're looking for least consistent. So this is scientist 1's theory. So you want to pick the answer choice that doesn't go with their argument. Scientist 1's evidence includes low water content, flying saucer shapes, and the absence of unmelted material. They mention narrow distribution of these fields is part of scientist 2's argument against that extraterrestrial origin. So C, the narrow distribution, is your correct answer. So I don't know how you tackled that, and I wish I was in class to ask you, but I just totally forgot that I have to take my daughter to her preschool screening. So if you did the strategy where you read all of it and you just underlined key points and then you answered the questions, or if you just read scientist 1 and went straight to the questions regarding scientist 1, then you went back to scientist 2 and answered questions about just scientist 2, kudos to you. Again, there's really no wrong way to do it. You kind of just have to go with what you feel at the time. But just know that save this passage for last. And when the time's running out, just make sure you answer every single question. So what we're going to do right now is I'm going to throw at you a really, really tough science passage, okay? Like literally you're not going to comprehend it at all. And so the secret to success with passages where you're completely lost is don't panic. Keep your cool, approach it in just a savvy, practical way, and remember your mantra. What does the figure show? What are the units? What's the pattern? What's the trend? Okay? So this next passage is about neutrinos. And I'm just going to run the clock here for 6 minutes. It starts on page, of course I whited it out, but it's right after 246. And it says the deep end, facing tough science passages. So now we're going to do something very cruel. We're going to throw at you a science passage of such technical difficulty that you will want to go screaming for the exit before you finish reading it. So we're going to do this for a reason. Sometimes on the ACT Science Test, you'll find yourself encountering a bear of a passage, one that seems entirely incomprehensible. The secret to success with these passages, like I said, is don't panic. As we'll show you, you can get points on even the most difficult science passage in the entire history of the ACT, as long as you keep your cool, approach it in a savvy, practical way. And so here's the passage, 6 minutes. Here we go. All right, that was 6 minutes. So let's see how we do. Question 8 was J. Question 9 was D. Question 10 was F. 11 was B. 12 was G. Okay, so, not a lot of background knowledge on that. They just talk about what neutrinos are, subatomic particles that travel at the speed of light. They can penetrate most matter, neutral, mostly massless, and then they kind of jump straight into 3 proposed stages to figure out, nuclear reactions. And then, you looked at those tables and figures, and you were probably like, what, right? So let's look at question 8. According to the information presented in the passage, which of the following stages or subpaths could contribute the smallest portion of the total solar neutrino flux on Earth? All right, so hopefully we were looking for some keywords here. Looking at figure 1, you notice that the options they give you is P-P. So maybe you were looking for that and you noticed that it was on table 1, but it didn't say really much of anything. PP1, PP2, and PP3, we're looking at subpaths. So basically, which stage or subpath contributes to the smallest portion of flux? So we're looking for a really, really small number. So when you looked at P-P, it's like 25%, right? PP1, where's that? 88%. PP2, oh my gosh, where's it? 12%. But then you notice PP3, whatever the heck that means, 0.01%. That's a pretty small number, right? So I hope you picked J, PP3. All right, not bad, right? Looking at question 9, of the neutrinos that are produced in the subpaths described in the passage, which type can have the greatest energy? All right, so this one you were looking at table 1, and you see that B8 right here has the greatest neutrino energy, except that our answer deals with N. And you're like, oh. So if we look at figure 1 and see that B8 is associated with N4, okay, so go back to figure 1, B8 associated with N4. So question 9 was D. So you probably got those 2 right. You're hot. Keep it going. Question 10. Based on the information presented in the passage, the percentage of solar neutrinos produced by BE7 subpath 2 is approximately. So it's referring to BE7 subpath 2. You may have noticed in the note under table 1, it's got the 2 little dagger marks. 2 dagger marks, BE7 subpath 2. Signify subpath 2. So far, so good. You notice that the choices are all percentages. Well, where are percentages mentioned? Oh, they were all mentioned in figure 1. So you find BE7 with 2 dagger marks in figure 1. You find it in the area of PP2, which is 12% in the x-axis of the chart. But you notice that BE7 with 2 dagger marks represents only part of that part of the figure. Okay, stay with me. 10% to be exact. So 10% of 12% is technically 1.2%. I feel like I need to show you. So, figure 1. Okay. The BE subpath 2. Right here. And we go, oops, where is it? 12% right there. BE7 subpath 2, 12%. Okay. What am I looking for? Where's that 7? Where's that 10? Part of the figure. 10% to be exact. Where's that 10%? This is embarrassing. Oh, now I see it. 10% of 12%. There. 10% of 12%. There it is right there. 1.2. So that's F4. Fantastic, right? Oh, there. I highlighted it. Why did I just trust myself on the next slide? I was like, where are my figures? So there it is. Okay, things get a little bit harder with question 11. Solar neutrinos are detected through a reaction of chloride 37, for which the minimum neutrino energy is approximately 0.8 MeVs. Of the neutrinos discussed in the passage, this method would detect what? All right, so you still might have gotten the answer if you used some common sense here. We're talking about some mumbo jumbo with chlorine, but the part of the question that should have caught your eye was the bit about the MEV, the minimum neutrino energy of 0.8. Neutrino E is represented in Table 1. Table 1 shows the 3 subpaths. Table 1's got the 3 subpaths. And they all have an energy greater than 0.8. Unfortunately, our answers are not expressed in these terms, so we have to translate it from the table to the figure, just like we did with question 9. So question 9, correct answer is B. So here are the 3 subpaths, 1, 2, 3, okay? And then using that translation to figure 1, right there. So the answer was B, sum of the neutrinos produced by PP1. Do I have a typo here? PP2 and PP3. All right. Okay, finally, question 12 talks about beta particles. Well, the beta particle appears only in subpath equation from the table 1. So there's that beta sign, there's that beta sign. We find beta symbols in the equations for all of the subpaths in the table, but question 12 is really asking, the symbol beta represents a beta particle, a particle emitted during the nuclear decay. Beta particles may be positively or negatively charged. During which of the following subpaths are beta particles emitted, which means given off? So we see that there's betas all over, but the key word here is given off. So we got to look on the product side. So that was P-P and B8. So G was your best option. All right, that was the rock hard bear of a passage. So 5 questions, 5 points. You may not have understand anything about neutrinos, but you could have scored some points just by understanding how to use some of those figures and graphs. Of course, if you understand the mysteries of neutrino flux and the PEP path subpaths, congratulations. When I first took it, I was like, ooh. But if you're like most ACT test takers, you're not really going to understand what the passages talk about, and you might feel lost. Okay, so just remember your mantra, right? Skim the text, go straight to the charts and graphs. Remember your mantra. What's the title? What's the units? Is there a pattern or trend? Hit the questions. Don't leave anything blank. Save your viewpoints for last. And if you gotta circle a letter, just pick one and straight down the road. Pick C or pick B, whatever your favorite letter is. But the moral of the story is just don't give up on a passage just because you don't understand it. You may not get every point, but you may be able to get some points, and the test is designed so you can figure out many of the questions even if you don't know the subject area. And if you still don't know, just make sure you guess. Okay? Some last minute tips. Don't read the instructions. You already know what the instructions are. Don't waste your time. Save that conflicting viewpoint for last. If you feel like you're getting stuck, then just skip it. Move on, okay? If you feel like you've spent like more than a minute and a half on it, just circle it. And if you have time to come back, great. Or just pick a letter, circle it, and like I said, go back and fix it if you do have time. Use the process of elimination. Pick your favorite answer to the bubble in, mark it. If you do have time to come back to it at the end, just don't leave anything blank. You're giving up free points. And keep your energy up. Like I said, science is the 4th test in this, so you're going to feel extremely fatigued. And if you're doing the write-in portion afterwards, even more fatigued. So, when they give you a break, take the break, okay? So that does it for my ACT prep. I hope it was helpful. If not, at least you saw some really rock hard passages, and when you do take your ACT, maybe the passages won't be as tough, right? All right. Well, good luck tomorrow. Make sure you get plenty of sleep.